Okay. Yeah. So specific means something, anything that is divided by charge. Okay. So, sorry, anything that is divided by mass. So if I say specific charge, it means charge divided by mass. So E by M ratio is also called as specific charge. Okay. So can you tell me, is E by M ratio constant for cathode rays or not?
Ma'am, it is constant, but for anode rays, it's not.
Very good. So for cathode rays, it is constant. For anode rays, it is not constant. So for anode rays, what does it depend on? Good evening, Nimarta. So what does it depend on for anode rays?
It can be any compressed gas.
Yes, so it depends on the nature of the gas present inside the Crookes tube. Okay, very good. Yes, Bhumika, nature of gas taken in the discharge tube. Very good. Okay, so now we have studied about protons and electrons, and now we are going to move on to neutrons. Okay, so neutrons were Rutherford. Yes, Pravalika. Okay. Good evening, Akshayani. So Rutherford was the first scientist to predict the reason for this discrepancy. The discrepancy that we're talking about is the weight of carbon atom. Scientists began to notice that the weight of the carbon atom was actually supposed to be 6 times the weight of the hydrogen atom, but in reality it was 12 times the weight of the hydrogen atom. The reason for this discrepancy was the presence of neutrons. So that means there is some particle which is giving extra weight to an atom but not giving any extra charge to the atom. So people started to realize that, okay, there must be another particle which has a similar weight to that of the proton, but it does not have any charge. So Rutherford was the first scientist to predict this discrepancy. James Chadwick was the first person to discover neutrons by bombarding beryllium nucleus with alpha particles. So did we guys do neutrons or did we not do this? All right, we'll do it anyway. So hold on one second. Yeah, so there is a beryllium strip over here and there is a polonium source over here. And this polonium source releases alpha particles. What are alpha particles? I will tell you in some time. But until then, just know that this region or this apparatus in this region has low pressure, okay? So that is why there is a vacuum pump attached to this. So alpha particles are released from the source onto the strip of beryllium, okay? So when these alpha particles hit, there is the beryllium strip, there is an unknown radiation that is released. That radiation is allowed to pass through paraffin wax, and then you can see that protons are released from this. So these protons are allowed to pass through an amplifier, an oscillograph, whatever, and then you observe how many or the intensity of the protons that is coming out. So basically what happened was when James Chadwick performed this experiment, he noticed that some radiation was observed. This radiation was found to be undeviated in the electric field. So he put this radiation in the electric field, but it neither moved towards the positive plate nor did it move towards the negative plate. So obviously this radiation is not charged. But then we have to find out if this radiation has particles in it. How do we do that? We do that by allowing this radiation to fall onto the paddle wheel. If the paddle wheel rotates, that means there are particles within the radiation. So to his surprise, he saw that there was motion in the paddle wheel. So he argued that the invisible radiation should consist of particles, as these particles are not deviated in the electric field, they should be neutral particles. Therefore, he decided to call these neutral particles as neutrons. So the mass of neutron is 1.675 into 10 to the power 24 grams. So if you notice, this is 1.675, 10 to the power minus 24 grams. Let's go take a look at neutrons. So for neutrons, if I look, it is 1.67 into 10 to the power minus 24 grams. So 1.67 and 1.67. So it's almost like very close. So the mass of neutrons is very, very close to that of protons. Okay. Did everybody understand so far? Okay, cool. Right, we did this. Okay, can you... Okay, we'll come back to this later. Okay, let's see if you guys can do this. Can you match the matrix? So what is column 1? Let's start with A. A would match to? A would match to Q. Okay, what would B match to? Okay, let's go back and take a look for that. So neutron. Look at the AMU value, 1.00866. Let's look at proton, 1.00727. That means the neutron is slightly, ever so slightly heavier than the proton. Okay. So the neutron is very slightly heavier than the proton. So let's come back to this. Yeah. So tell me, what is the option D? R. Very good. Option C? S. Very good. And option D is obviously the one that is remaining. So can somebody tell me why is option D 4.18774? What all does option D contain? What all does the helium nucleus contain? Can you tell me? 2 protons and 2 neutrons. Very good. Okay, good. Yes, you guys are right. 2 protons and 2 neutrons. Okay, let us proceed.